When you're multiplying like bases, you do what with the exponents? Do we have any, that is correct, do we have any like bases? The 5s, okay, good. So then, right, say it again. Well, be careful because the base stays the same. This is a 1. So how about like that? When you multiply like bases, you add the exponents, you leave the base alone. Right? Because like x to the 3rd times x to the 4th is just x to the 7th. It's not like 2x to the 7th or something, right? So then same way, 5 to the 3rd times 5 to the 4th is only 5 to the 7th. Is that okay?
Yeah.
All right. A lot of rules to keep straight. So does it make sense then, since this was 5 to the 1st, oops, sorry. That's 5 to the 1st, then 1 plus negative 1/2 is positive 1/2. Is that okay? All right. So then let's, we'll just do this. And is it okay if down here I give it to both of these? Well, right, there's a 1 there and a 1 there, so we can multiply both of them. So then 5 to the 3/2, x to the 3/2. Is everybody happy with that? Right, this is all from those old rules, right? Multiplying like bases, add the exponents. Power to a power means multiply the exponents. So now we're dividing. I did not. I got that one up there. You mean? No? That didn't work. Oh, well, just choose it up. There, do you want those? You're not going to catch up with your eye, are you? No. Okay. All right. Yep. I got a ton of them. Keep that one to remember me by when I'm gone. All right, so we're dividing like bases. So what are we doing with the exponents? We're dividing like bases. So what are we doing with the exponents? Subtract them. So 1/2 minus 3/2 is negative what? Yeah, 1 because it's negative 2/2. We'll leave it like that for a second. And then when we're dividing like bases, we still subtract the exponents. So then it's x to the 1st because it's 2 over 2 again. So then we can write it like you guys were trying to tell me to do it. Now that's not quite done. Why is that not quite done? Yeah, so what do we do with that negative exponent? So the x is going to stay there in the numerator. The 5 is going to drop down. Is that okay? Okay, I know there's a lot of rules going on. You got to try to work through them. The more you practice, the better off you're going to be. So, we still got those IXLs. Those are still due Friday. Today's Wednesday, I believe. If you need more time, like ideally you say, okay, I'm feeling better about my exponents. I'm going to revisit 1 to 69 odd and correct the ones that I'm not sure of. Okay, that's ideal situation. There's not a lot to this assignment because I found out last period that people are having a lot of trouble. So we're going to kind of ease into it. There are some prerequisite rules that we got to get straight first. Did you get it? Here's a little math for you. That's a definition. That's a statement, basically. You need to accept that it is true. Is there anyone want to say anything about it? Anything that you notice about it? Yeah, in fact, it has to start the same. Okay, so if, it's kind of like if these are the same, these are called the indexes, or indices, I guess. If these are the same, then you're allowed to multiply the inside stuff. Is that okay? So, as an example, square root of 3 times the square root of 7 would be what?
21.
Square root of 21. Square root of 21. Is that okay?
Yeah.
Cube root of 5 times the cube root of 25 would be the cube root of 125. Now, of course, you should be checking to simplify. Why is it just 5? Well, yeah, I mean, yeah, the easy answer is the cube root of 125 is 5, yeah. But right, we could break this down into 5 times 5 times 5. So there's 3 5s. Group them as 3s.
Yeah.
Is that okay with everybody? All right. Make sure your all's noses are in those masks, please. You never know who was here before you. All right. So is everyone happy with that rule? Indexes have to be the same. And as a sidebar, you can go from the right-hand side to the left-hand side too if you want. Okay, that's also fine. All right, and that's going to play more into this statement here. That is also true, which is basically the same thing as that last one. So sometimes it makes sense to be here. Sometimes it makes sense to be here. But again, the index has to be the same. Is that okay? Anybody got a question so far? Ask now. I want to answer your questions. Yeah.
What if the index is parentheses?
So, which is a very good question. There is, you are allowed to multiply and divide anything you want, no matter what. If the indexes are not the same, you would have to manipulate them to make them the same. That is nothing. Well, I do not think that you will actually have to do that in here, but I can show you an example of that if you'd like to see. You want to see it? Yeah. Like that. All right, so I will show you that. It's not the worst thing in the world. But since he asked, let's do it. It's a good question. Uh-oh, there's trouble.
Okay.
I know. She has like 5 of them over there already. I never see you bring them back. All right, let's say we'll just do an easy one. Let's do square root of 2 times the cube root of 3. Let's see, how do you do this? So then this would be 2 to the 1/2, and then this would be 2 to the, oh, sorry. That would be 3 to the 1/3. Is that okay?
Yeah.
Because we need this too. Well, that's just how you move it around, right? There's a 1 there and a 1 there. So then the root is the denominator.
Yeah.
Okay? So then what we need is these roots to be the same. So this is like a common denominator problem. So would it be okay if I said this?
Yeah.
And then would it be okay if I said that?
Yeah.
Right? That's just kind of going in the opposite direction of reducing. So then what we could say is if we multiply these together, we could say that we would get the 6th root of 2 cubed times 3 squared. Is that okay?
Yeah.
So you can actually do it. I don't think you're going to have to do that in this section, but it is totally possible. Is that okay? Is that right? All right, now we're going to add and subtract these bad boys. May have to do it one day. Maybe I'll put that on the quiz. We got a quiz eventually. One day you guys will actually have to take a quiz on here. Boy, I can't wait. Super easy question. What's that? 3x. Okay, good. All right, so if you're adding radicals or subtracting radicals, you are kind of thinking about like terms. For instance, the square root of 2 plus the square root of 3 is just the square root of 2 plus the square root of 3. But the square root of 2 plus the square root of 2 is 2 square root of 2. Is that okay?
Yeah.
So what that means is not only the indexes have to be the same, but the innards of the radical have to be the same for you to add them together. Is that okay with everybody? You just keep saying, yeah, I hope you're agreeing. I mean, you are agreeing, but all right, so then let's do 3 square root of 10 minus 5 square root of 10. What is that going to give you? Is that okay? All right. One more of these examples. What about, good, 5 square root of 2 plus 6 square root of 8? I'm telling you, you can do that one. But they are not like terms right now. 11. Don't mess with it yet because these are not like terms right now. But this one should make you want to do something. Okay, so she's saying, right, she basically did this for you guys. 2 and 4 and 2 and 2 to get to 2 cubed. Why does that help you? Yeah, so we can group that, right? And then we'll have like terms. So then just be careful with that grouping. What happens is it goes, this stays the same, plus 6 times that 2 that we took out right here, square root of 2. Now we do have like terms. Good job, by the way. So then really what we have is 5 square root of 2 plus 12 square root of 2. Oops, sorry. 17 square root of 2. Is that okay with everybody? So, they have to be, oh! Whoa. What the heck? It just gave up. That was like a drop of the mic kind of thing. My camera did it on its own. Like, that was such a sweet move. I'm just proud. All right. I don't even know what I'm so excited about that new button. I don't even know what to say. I lost my train of thought. Oh, make sure they're like terms. And if they're not like terms, make sure you check to see if you can make them like terms before you say you can't add them. How are we feeling? All right, here's where I lost people before. So make sure you ask. We are in the book. We're in a new, not well, in the same section, but a little bit shifting gears here. So page 25. 1 to 5. Let's look at 72. 25. Gotta be good at taking notes in here, I tell you what. Woo! Oh, I'm doing 72. Taking you guys out. I already did 70. There we go. All right, 25, 71 through 74 says, rationalize the denominator. Now, if you had me last year, we rationalized before, but that doesn't mean you remember what it means. Here's what rationalize means. I'll even write it down for you guys. I like you guys enough to do that. Rationalize right? All this means is make sure the radical is not in that part anymore. That's not exactly the math way to say it, but this is what you need to know. Make sure the radical is not in that part anymore. Okay? So the directions on this are saying rationalize the denominator, which means make sure there's no radical in that denominator when you're done. This is not an equation, it's just an expression. And what that means is our only option is to multiply by some version of 1. Because we're not really changing anything. So this is a nice simple one. So let me explain kind of what we're going to do here. Again, our problem is the square root in the denominator. Square root is asking for group sizes of what? Of 2. How many 10s do we have? This is number 72. We have 1 10. That way we can't get rid of the radical at this point. We need 2 10s and we can get rid of the radical. So then we're going to multiply by another square root of 10. Now whatever we choose there, we have to multiply the numerator by, because we can only multiply by a version of 1. Is that okay with everyone? Alright. So, what does the numerator become? Oops, sorry.
5 square root of 10.
5 square root of 10, good. And what does the denominator become?
The square root of
Square root of, you can do it square root of 10 squared, which is 100. But what is the square root of 10 squared?
10.
10. So then we have 5 square root of 10 over 10. How's that? Does that make you feel all mushy inside?
Yeah. Talk about much inside. I thought you were just like good.
Well, I use mushy and good interchangeably. As I like see my wife, I'm like, you look pretty mushy today. Doesn't always work out, but we're not quite done here though, because 5 divided by 10 is 1/2. So really, this would be the final answer. Oops, sorry. It's like I like that pizza you made is awful mushy. We got a different kind of language at my house. My sons have actually do this thing, which I think is really cool, and I think we should all do it. Like they substitute like sounds in instead of words, and often that makes more sense. Like like oh, we were going down, and it was like, and you're like, dude, I know exactly what you mean. I feel like we should do that all the time. Mostly, I'm a grunter. My mama was a grunter. My mama's mama was a grunter. So, go figure. Let's see. Do I have enough room for B here? I mean, I got enough room. No, I don't have enough room. I'm going to erase this. Can I erase the rationalized part of it too? Now, Zach, if you ever meet my mama, do not tell her that she's a grunter. That she'll kick you in the teeth. Better believe it. Do I think you can call my mama a grunt? No, my mom is she's a sweet old lady now. Why would you do that? All right. I'm going to make this a little bit easier for you. The same rules. We got this radical in the denominator we don't want. I'm going to make this a little bit easier for you by doing this for you. I do this for you guys because I like you guys. Uh-oh, what's happening? Can you read that? Do you see that? Those are 2's in there?
Yeah.
All right. So what's our goal again? We got a goal. We got to have a goal. Well, okay, so how do you know when you get to the answer?
No more work to do after.
But how do you know? That's true, but we're also rationalizing the denominator, which means no radical in the denominator in this case. So this is a little bit different because now we have group sizes of 3. How many 5s do we have down there? 2, but we need 3, so how many more do we need? 1. I'll do this in red for the people that are not colorblind, I guess. Cube root of 5. Of course, we got to do that up here too. What about how many more x's do we need? 1. Now, does everyone understand why it's just a 5 and an x in there? Yes, sir.
Why didn't you put the denominator and numerator?
Well, so we want. Well, like, are you asking about this stuff over here?
No, why didn't you put the? You gotta have the when you put the denominator and the denominator.
No, hold on. Let him talk. Go ahead. Say it again. When you do what?
You gotta put it in the numerator, right? When you multiply.
Okay, so again, we're trying to get rid of this radical, and the only way we can get rid of the radical is if we have enough groupings. So we need everything inside. We have to have 3 of, so that we can get rid of the radical. So we have 2 of each. Is that okay? But we need 3, and so then that's where this and this came up, and that's the only thing that you're deciding on. And then you have to do the numerator by the same thing you decided down here. So then this part in the red is only because of this part down here. Did that answer your question? All right, we'll do more. Don't worry. We'll do more. I know this stuff is a little confusing and obnoxious. Like, would it help if I look at it?
Yeah.
All right. I'm not really sure what you're asking.
Why didn't you put that?
Because, okay, all right. So here's what he's asking. This is actually a good question. All right. You guys laughing, but no, it's a good question. All right, so what he's asking is, right, we're going back to the start here. Was it on this one or here? Like just like this? Is that how you got it?
Yeah.
Okay. So this question, because like if you know what you're talking about, you'll be able to answer this. So he's asking, why don't you just do this? Oh, sorry. Because that's what we did on the last one. So why aren't we just doing that on this one? So, well, the parentheses aren't really, this is just how he had it written. I mean, these two things are the same up here. But, like, why can't we just grab it like we did on the other one? Yeah, because we got.
You would be left with 4 squared rather than 3, so then you would still have 1 extra one.
Okay, so yeah, right, exactly. So, okay, so here's what she said. Right? We need group sizes of 3, right?
Yeah.
If we just grab this and redo it, then we're going to have 4 5s. And so then we got a whole group, but then we have this extra one that's still inside the radical. And that doesn't get us what we needed. We got to have some version of groups of 3. So if you're really like crazy, we could do like 6 more, or well, I guess 4 more to get to 6. But that would be overkill. Okay, so again, this doesn't work because we need group sizes 3, and we now have 4. Is that okay? That's a very common thing for people to do when they're, the square roots aren't too big a deal because you just grab it and go. Does that kind of help? I know what you're asking. I don't know if the explanation made you feel happy or not. But this works because now we have 1, 2, 3 5s and 1, 2, 3 x's. All right, so then what happens in the numerator? Okay, so what do we get?
5 cube root of 5x.
And then in the denominator we get
Cube root of 5x cubed.
okay, so I'm gonna, since I did it like this, I'm gonna write it. You're basically right, but I'm gonna write it like 5 cubed x cubed, and so then that's 5 cube root of 5x over 5x.
Would this 5 cancel or no?
Yep. All right, where are you lost?
So you have cube root of 5x over x.
All right, so here, let's look at it again. Right? Remember what our goal is. The only thing that we're being asked to do is getting that radical away from the denominator. We don't want it. We can't get rid of it altogether. Okay? Because then we're just changing the problem. So we have to multiply by some version of 1. Yeah, we got.
How'd you go from 5 times? Like, I don't know how to ask the question, but
Where am I looking?
the top red, how do you do that?
Okay, so this is the one that we created. Right? Our goal is to get rid of this radical here. These are fine questions. These are fine. Right? That's our goal. The only way we can get rid of this radical is if we have groups of 3. Right? Just like, let me go down here. Right? If we were doing the square root of 8, right, that's just 2 square root of 2. We had this extra 2 because we had 3 2's. So we couldn't get rid of them all. But you can do the square root of 4, and that just becomes 2 because there was just 2 2's there. Is that okay? All right, so then up here we had to create something, some number, that gave us group sizes of whatever this is, in this case 3. So we had to come up with that. We knew we had 2 5's, so we needed 1 more 5, and that's where that came from. We had 2 x's and we needed 1 more, and that's where that came from. We had to put it in the cube root. So then when we multiply, we're allowed to multiply the inside numbers now. And so now 5 squared times 5 is 5 to the 3rd. X squared times x is x to the 3rd. And now we have our groupings that we can get at, which is why we can go here. Is that okay? I know. Say it with me. I love me some math. How come no one said it with me? Lauren.
Math is mushy.
Math is mushy. Math. Math is mushy. All right. How was that? Was that pretty awesome? Yeah, let's do 71 together. Everyone do 71 together. That's part of your homework, 71. So everyone try 71, A and B. Part of your homework. Look at that. Just because you're here, I do some of your homework with it. Don't thank me now. It's okay. I'm used to it. Math, oh how I love you. Let me count the ways. 1, 2, 3, 4, 5, 6, 7, 8. Did you get it? What's that? Oh yeah. Oh yeah. You got it. You got it. Oh yeah. We got some people with it. Oh yeah. Here we go. You got it? Let's see it. Well, we're still rationalizing the denominators. We just don't make our radical 3 down there. Except for that should be 3 on the square root. Right? 3 square root of 9. Yeah, 3 square root of 9. Yeah, we got it. That's what I'm talking about. Right? How many group sizes of what?
3.
There Scream it from the rooftop, Lauren. You got it. That's what I was going to scream. You got it. Yep. So, right, we got group sizes of 2, so we need one extra 3 down there because we only got one of them. For my people, they got it. How's that feel? That feels all good. Mushy, that's right. And it's mushy inside. All right, let's see how you guys do now. Let's go to B, 71B.
You have to multiply it.
How are we doing on time? We're doing all right.
11 minutes.
We're doing all right then. We'll do this one. All right, do down there. That's the second part of 71. Sure. Let's walk through it. Right? What's our goal here?
You need to mark it.
So we're trying. Our goal is to get, the radical needs to not be there anymore. So what group sizes are we looking at?
I don't know.
This is the radical. Okay. So we need group sizes of 3. Good. So then, how many more 2s do we need? 2. Yeah. Right. So we made our decision down here, and then we just had to bring it up top. We can't. We got to do that move. So that's now you're just multiplying. So 8 cube root of 4 over. I'll write it out. Cube root of 2 cubed now. So that gets us to 8 cube root of 4 over 2. And now this isn't quite done yet. What else should you do? Yeah, so then the final. All right. Now, of course, you can check in the back of the book, but also, like if you're doing this with the calculator close by, you can always put in 8 divided by cube root of 2 and hit enter, and then come down and put in your answer 4 cube root of 4, and it should give you the exact same thing. We're just moving stuff around. How's that feel? All right. Now there's one other thing that could happen. So we're looking at 74. 74. We'll erase this. Is that okay? Oh! You can't tell I was above it. It's a projector joke for the.
But my question is,
Yep.
like, how do you know when you're going to square?
So, like you're saying, like, why did I do this?
Yeah.
Because we needed 3 of them, and right now, right, there's just a 1 there.
So you do it like when you can't get groups of 3 of, so you can't get groups of 3 of.
Yeah, you can't get a group out right now until we get 3 total, and so that's why we added 2 more to it. Yep. Yep. Exactly. Stop it. You guys are laughing at him, and like now he says he has it.
You can't get 3 groups of 2. So you can multiply it.
All right, this one. We gotta move on. We gotta get to this part. You'll have more time to answer. Get questions answered. Can I erase this now? Yeah. All right, this one. You guys had that last year. You can't tell me you don't. Well, you can tell me you don't remember it, but we totally talked about this. Right? This is a conjugate. We gotta multiply by conjugate. What is a conjugate again? Does anyone remember? Conjugate. Conjugate's super easy to create. Use the same 2 numbers, because again, we're doing the same thing. We don't like this radical down here. Same 2 numbers, opposite sign. So we have to multiply by 5 plus radical 3. That's how you make your conjugate.
That's right.
Remember that?
Yeah.
All right, conjugate's super easy. Same numbers, opposite sign. And now we have to distribute and FOIL. So then we're going to go 10x plus 2x radical 3. So Sorry, I gotta go fast to get through this. We got a couple more minutes.
And then you have.
Oh, sorry. Right there. And then we get 25 plus 5 radical 3 minus 5 radical 3 minus the square root of 9. Move that over. And so the whole point of the conjugate is this thing right here. Right? Those two cancel out because then we just created a square root of 9, which is, 3. So you understand where the conjugate came from? Okay, and then we're just distributing up in the top. 2x times 5, 10x. 2x times radical 3, 2x radical 3.
The other thing I don't remember about the conjugate is, how do you know if you add or subtract?
It did whatever you started with. So we started with a negative, so then we had to make it a positive.
No, like,
Oh.
go to the red one.
This?
It's like when you, foil, sorry.
Yeah. So, right, so this is positive 5 times positive 5, so positive 25. Then positive 5 times positive radical 3. Negative radical 3 times 5.
So if it's positive, it's plus. And then it's
I got it? No. Alright, so then 10x, I'm going to simplify this for you quickly. 22. And then hopefully you notice that we can simplify all of these by 2's. So I'm going to go in this direction. I'll write it out and you can tell me. Give me a second. Alright, so all I did was I factored out a 2 at the top and then simplified the 2 over 22. I'm going to remove my thing. How's that? Super cool. Alright, so I gotta do one more for you. All you guys gotta do today is 71 to 79 odd. Yep. I'll do one more for you guys so you can get on. I know it's not very many. I apologize for you guys that are low time. That should be plus. That needs to be plus. Otherwise, okay, so you just have the problem. So, right, like, if you guys, without changing that to a plus, you don't cancel things out. That's what happens. You have to change this one to the opposite side. Okay, so, like, if you guys are doing conjugates and you don't get things canceling out, that's probably because you didn't switch the sign. Okay? What do you do if you don't know how to do it? Well, I mean, there's always, like, there's examples in the book you could look at, I guess. Or, I'm recording it. You can watch the video again. Is there audio? Yeah. Oh, I think so. That's a good question, though. I'm pretty sure. Alright, this one won't take very long. Yeah, there's audio, man. I wouldn't leave you hanging like that. Alright, we need to reduce this. I gotta do it quick. Ready? We gotta change it to its other form. Does everyone know where that came from? 3 over 6 reduces to what? To 1/2. Good. And then there we go. That's pretty easy. Okay. If you really have trouble and you got next period off, you can stick around. I can help you. But we're gonna